Okay, so now that we understand what a vector is and how to represent it both algebraically and by its magnitude and direction, what can we do with them? So we have some operations that we can perform on our vectors. Here is a summary of our operations, and we're going to work a couple of examples for you to be able to see them at work. But basically, it's as if you're adding the x components. Like, let's look at this first one right here. So the first line right here says that if I have two vectors and I wanted to add the two vectors together, then I would add their horizontal components together, and then the next part would be their vertical components. So it's pretty simple. So you end up with a new vector here, which is a combination of both horizontal and vertical values. The next line is illustrating what happens if I multiply a scalar. So this value right here is just some number, some integer number, and I am multiplying it by the vector. So when I do that, I just multiply each of the interior components, the horizontal and the vertical components, by that scalar value, and I've created a new vector here. The last two lines I think are rather intuitive, and you can look at them either way you want. First of all, this first line is basically saying if I have the vector u given by these components here, then the negative u would be those components, each with negative signs. And then the last one here, which is the difference, if I have two vectors that I am taking the difference of or subtracting two vectors, I can either look at it in this form right here where I am subtracting the horizontal components and the vertical components from the original one, or we can look at it as adding the negative. Either one. So let's practice a few of those down here in these examples. Here I have the vector u and v given by these ordered pairs, their horizontal and vertical components. I have a graph of what we're talking about over here on the right. And I have three examples that we're going to look at. The first one being I just simply want to add vectors u plus v. So when I'm doing that, again, I am just going to be adding their horizontal components along with their vertical components. So I'm going to write this as -2 plus 4 because those are the horizontal components of the two vectors, and then the 1 plus 3 because those are the vertical components of the vectors. When we simplify that, we can see that that would be +2 and +4. So this is the new vector created by adding vectors u plus v. Now I don't assume, or I do not think that you're going to actually take the time to do this step right here, but I want you to understand how I'm getting these numbers. If I wanted to then go back and graph this new vector, let's go back up to this graph we started with. The new vector, when I added it, was given by the ordered pair over 2 up 4. So if I were to draw a dot right here representing the point 2, 4, then coming out of the origin is this ray, and that red line right there is representing the sum of vectors u plus v, which created a new vector, which is the one in red. Let's practice that again with scalar multiplication. In this particular case here, we're going to take each of the components of vector u and multiply by -2. So I have a -2 times the -2 already there, -2 times the 1 that's already there, giving me a new vector which looks like 4, -2. So this would be my new vector here. Okay, and then I want you to practice this one right here, and we'll come back together and check our solutions. So here is the solution that I have when I take 3 times vector u and subtract 2 times vector v. I end up with -14, -3 for my components. There's all sorts of different ways. Well, I guess there's maybe 2 ways to be able to work this. But in this first one, when I represented vector 3u, I ended up with -6, 3. But I went ahead and I took -2v, this should be v, so -2v, and I multiplied the -2 times its v components, giving me -8 and -6, at which point I then added straight down for the horizontal components, giving me -14, added straight down to give me the vertical components giving me -3. So I chose to add because I first multiplied by a negative. If you had just multiplied by a +2, you would then subtract, and you end up with the same values. So these are just a few examples of how we would perform operations with our vectors.